Test of divisibility. A number is divisible by another number if it is a multiple of that number. For example, 24 is divisible by 3 because 24 is a multiple of 3. It can also be stated that a number is divisible by another number if it is exactly divisible by the second number and leaves no remainder. 24 is divisible by 3 because it leaves no remainder. So 3 can also be called the factor of 24. Rules of divisibility will help you find out whether a given number is divisible by another number exactly, without leaving any remainder. Divisibility rules. Divisibility by 2. A number is divisible by 2 if it is an even number. Even number ends in 0, 2, 4, 6, or 8. Example, 4106. Divisibility by 3. A number is divisible by 3 if the sum of the digits adds up to a multiple of 3. Example, 435. Divisibility by 4. A number is divisible by 4 if it is an even number and can be divided by 2 twice. Alternatively, if the last two digits of a number are zeros or divisible by 4, the number is divisible by 4. Example, 4764. Divisibility by 5. A number is divisible by 5 if it ends in a 5 or a 0. Example, 2605. Divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. Alternatively, if any even number is divisible by 3, then it is divisible by 6. Example, 6780. Divisibility by 8. A number is divisible by 8 if the last 3 digits are divisible by 8 or the last 3 digits are zeros. Alternatively, if any even number can be divided by 2 thrice, then it is divisible by 8. Example, 4808. Divisibility by 9. A number is divisible by 9 if the sum of the digits adds up to a multiple of 9. Example, 9243. Divisibility by 10. A number is divisible by 10 if it ends in a 0. Example, 8750. Divisibility by 11. A number is divisible by 11 if the sum of the digits in the odds place is equal to or 11 more than the sum of the digits in the even places. Example, 4224. Divisibility by 12. A number is divisible by 12 if it is divisible by both 3 and 4. Example, 1248. Divisibility by 15. A number is divisible by 15 if it is divisible by both 3 and 5. Example, 135. Prime and composite numbers. Prime numbers. A prime number has only 1 and itself as factors. Composite numbers. A composite number has factors other than 1 and itself. Numbers 0 and 1 are neither prime nor composite. Sieve of Erosthenes. A Greek mathematician named Eratosthenes gave a method for finding out the prime numbers between 1 and 100. This is called the Sieve of Erosthenes. Now do these in the Sieve of Erosthenes. 1 is neither prime nor composite, so cross it out. 2 is prime. Cross out all even numbers greater than 2 in red. 3 is prime. Cross out all numbers which are greater than 3 and divisible by 3 in green. Cross out all numbers which are greater than 5 and divisible by 5 in blue. 7 is prime. Cross out all numbers which are greater than 7 and divisible by 7 in yellow. Now look at the table. Numbers that are circled in purple are all prime numbers. HCF and LCM. Prime factors of a number. The factors of a number that are prime numbers are called prime factors. For example, the factors of 6 are 1, 2, 3, and 6. Among these, 2 and 3 are prime numbers. So 2 and 3 are the prime factors of 6. Factorization. Factorization means expressing a number as a product of its factors. For example, 12 can be expressed as the product of its factors in the following ways. 12 equal to 1 into 12, 12 equal to 6 into 2, 12 equal to 4 into 3, 12 equal to 2 into 2 into 3. Prime factorization. Prime factorization of a number is the method of expressing a number as a product of its prime factors. We can find all the prime factors and prime factorization of a number by building a factor tree. Building factor trees. Let's look at the following example. Find the prime factors of 48. Step 1. The factors of 48 are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Step 2. Start with the smallest prime factor of 48, that is 2. Step 3. 48 equal to 2 into 24. Circle 2 as it is a prime number. Step 4. The smallest prime factor of 24 is 2. 24 is equal to 2 into 12. Circle 2 as it is a prime number. Step 5. The smallest prime factor of 12 is 2. 12 equal to 2 into 6. Circle 2 as it is a prime number. Step 6. The smallest prime factor of 6 is 2. 6 is equal to 2 into 3. Circle both 2 and 3 as they are both prime numbers. We stop building the tree here. Thus, the prime factorization of 48 is equal to 2 into 2 into 2 into 2 into 3. Highest common factor, HCF. The highest common factor, HCF, of two numbers is the highest number that is a factor of both numbers. Let us find the common factors of 16 and 18. Factors of 16 are 1, 2, 4, 8, 16. Factors of 18 are 1, 2, 3, 6, 9, 18. The common factors are 1 and 2. Of these, the highest common factor is 2. So the HCF of 16 and 18 is 2. Least common multiple, LCM. Multiples of a number are obtained by multiplying a number by a whole number. Multiples common to two numbers are called common multiples. The lowest common multiple, LCM, of two numbers is a multiple of both the numbers and is the smallest among the common multiples. For example, let's find out the LCM of the pair of numbers 6 and 8. Multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, and so on. Multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, and so on. Now the common multiples are 24, 48, 72. The smallest common multiple is 24. That is, the LCM of 6 and 8 is 24. Relation between two numbers and their HCF and LCM. There is an interesting relation between two numbers and their HCF and LCM. HCF into LCM is equal to product of the numbers. The HCF and LCM of 6 and 8 are found as follows. LCM is equal to 2 into 2 into 2 into 3. That's equal to 24. The HCF of 6 and 8 is 2. Now write the product of the numbers. 6 into 8 equal to 48. Write the product of LCM and HCF. 24 into 2 equal to 48. Now you see that the product of two numbers and the product of the HCF and LCM are the same. Isn't this relation interesting?